Hello minions, hello enthusiasts, welcome to the next session, and today we are going to talk about thermal physics, a very simple chapter but very important chapter because it's going to give you a lot of marks. And guys, I feel if I were you, I would definitely prepare those chapters which are easy and which will fetch me marks rather than in the last moment, of course, rather than just worrying too much about the difficult chapters. So let's talk about temperature, let's talk about thermal expansion, zeroth law, so many problems that I have planned, including some mains plus advanced questions, and we are going to also talk about heat and what is temperature. So all with me, your master teacher for physics at Vedantu, and also who teaches physics for this channel, We Enthuse. So welcome all the We enthusiasts, welcome all the minions. How are you guys doing? And what a lovely session it was yesterday. I'm so glad to see all of you out here again. Hello Ankit, Yalni, Shreyas. All right, somebody has taken just my name. Wow, interesting. Hi Nirupam. Hi Vishnu. Hi Neeraj. Hi Saktivel. Hello Uncharted. Good evening. Hi Kirito. Welcome Dhanush. I hope I'm not missed out anybody's name, but in case I have missed out anybody's name, understand sometimes it happens that while scrolling through the chat, I might miss some names. All right. Hello VK channel. Hello Misha. Hello Ankit. Hello everyone. So those of you who are new out here, so this is Shreyas here, and guys, I have been training kids for a very long time, and I am here only because of few things, guys. See, one thing is because I obviously love teaching. Number two, I love physics. Number three, it's your support and that love which provides me all the strength. That's it. So these are the three main reasons why I'm here, and I'm really been fortunate that many of my students have not only just cracked the exam, some of them have even got 2-digit all India ranks. Yes, below all India rank 100 in JEE examination, and I'm really glad that some of them have also made it to IITs, NITs, BITS, and so many other institutes. And see guys, it's not just my teaching that helps, but also it's their hard work, the students' hard work, which has made them get there, and I'm pretty sure you are also going to reach there. So guys, there are some really cool announcements and really cool videos that will be coming up in this week, so do not forget to follow me on Shreyas_Vedantu. That's my Instagram handle out there. Hello everyone, glad to see everyone. Hi Sneha. Hi Priyanka. Hello Science Priya. Hello Shankar. Welcome aboard. And I hope you have already subscribed if you're here. All right, because that's free, guys. Come on, you will get all the important news updates out there. And I hope you have already smashed that like button, because that's how you're going to show us your support, your love for this channel. Come on, go smash that like button if you have not done that yet. Now, this is this week's timetable. I'm pretty sure you would have watched this video, how to wake up early. In case you haven't, please watch it. KVPY sessions lined up out here. So on Monday and Thursday. Today we're going to talk about thermal physics. Friday it's a marathon session. Keep in mind it's at 8:30 p.m. not at 7 o'clock. It's at 8:30. So please have your dinner. Please have your food and only then attend this session, because it's going to be a long session. So marathon session on Friday, and Saturday a special session with a special guest, of course, and you will get to know more about it on Saturday, 7 o'clock, that is. Okay, so special session on Saturday. All lectures are at 7 o'clock unless specified otherwise. So like you all know, marathon sessions are being conducted by Shimon Sir, me and Wazim Sir. So the respective schedules obviously would have been shared by Wazim Sir and Shimon Sir. So please check it out. So these are very important sessions, so that it's a power-packed series, many concepts in that one lecture, but it's an extended lecture. Menti quiz on Saturday in the morning, 8 o'clock. In case you have missed chemistry Menti, go check out the video. So do not forget guys, wake up early, and if you do not know how to wake up early, please check the video which I have just made yesterday. All right, so let's begin with our session, guys, and let me also tell you some important things which will help you. So I know some of you really want to boost your performance out there. See guys, in the last few days, what is very important? What is very important? See, I feel there are few things which will really boost your performance. Number one, revising all the concepts, important concepts, scoring chapters. That's number one. Number two, somebody who will push you always, make you solve some problems. Number three, also you want your doubts to be clear. See, Normally, if you are studying in, let's say, 11th standard, I would say that, okay, if you have a doubt, you have to think about it. Even if you waste one day, it's not an issue, but you solve it yourself. But in the last few days, last few weeks, I'm pretty sure you don't have that much time. Number 4, identify your mistakes. How? By solving test papers. Very important, solving test papers and identifying all your mistakes, and then analyzing it and making sure that you're not repeating it. These things, and plus some tips sessions, strategy sessions, just like we conduct on Enthuse. Imagine AP sir, Pulkit sir and other great master teachers teach you all of this. So this is what has been offered in the crash course. This is for only 12th and the dropper students out there. Remember, you don't have any other choice out here apart from this crash course, which in these last few days, because this crash course is the only thing which will boost your performance, guys. See, whether you buy the crash course or not buy the crash course, you enroll or not enroll, that's another thing. But I feel that these things should be done. It's okay, even if you enroll into a crash course in some other institute, it's okay. That's not a problem. But make sure that whatever you do, it covers all these pointers. Your doubts should be solved, papers should be practiced, they should be discussed, you should identify your silly mistakes, all tips and strategy sessions should be there. It should be a two-way kind of a session. Your doubts are getting solved then and there itself. All these things are important in the last few days, guys. Boost your performance even by 5 marks. I am okay with it, because 5 marks will give you a big jump in your ranks, and that is what is important in these final days. I am telling you this from my personal experiences over the last few years, when I have been training students and coaching students. So very important, these last few days. You don't know, you might have studied really well, but suddenly a person who was scoring maybe 180 marks suddenly comes to 220 marks. Why this happens? Because he has done something extra. So it's very important that you put in your full 100%. So if you want some assistance, we are ready to help you in this crash course for all the 12th and the dropper students. You can please go out and check the link. Every detail about this crash course has been mentioned, and usually the price is 10,000, but you'll get 20% off if you use this coupon code, which is SHCC21. So go ahead, check it out, and if you feel like, definitely enroll into this crash course. Don't leave any stone unturned. All right, now let's first talk about temperature, guys. Let's talk about temperature first. Well, Aishwarya, I will look into the Telegram group link. If it is not working, definitely just ping me on Instagram. I will share you the link, because some people said that the Telegram link was not working. I've shared them that link as well. Yes, okay. So I hope I have answered most of your doubts. And guys, please remember, if I'm unable to answer any of your doubt by chance in the chat, maybe I skip for some reason, all right, please post it up in the comments, or you can definitely ping me on Instagram out there. Now, what is temperature? So guys, first of all, temperature tells you how cold or how hot a body is. Sun is very hot, oh, the ice is very cold, oh, body temperature is normal, oh, the car's engine is very hot, oh, this ice blocks are cold. So it basically tells you the degree of hotness or coldness, but that was your 9th or 10th standard definition in science. Now you have grown up, you have matured. The definition actually for temperature is the measure of the average kinetic energy of the molecules. Very, very important definition, guys, is the measure of the average kinetic energy of number of particles. That means, understand guys, temperature, very important, temperature is a function of the average kinetic energy. What is the meaning of average kinetic energy? K1 plus K2 plus K3 plus n number of particles are there, correct? This total kinetic energy divided by the number of particles. So it's some function of the average kinetic energy. What is that function? I'll be telling you in a couple of lectures, but for now just remember it's a function, some function of the average kinetic energy, because the particles will be moving randomly here and there. So that's why, okay? Then it makes sense that if the particle's kinetic energy increases, obviously the temperature should increase, and similarly if the kinetic energy decreases, then the temperature should also fall down. So guys, whenever you touch a hot object, let's say this pen is really hot. When you touch it, the molecules of the pen are vibrating, are translating, are rotating very fast. They have a lot of energy. And when my cold hand touches it, those molecules hit my molecules of my hand, they rupture the skin, and that's how I feel it as hot. Similarly, if this pen is very cold, what is happening is The molecules of my hand are moving really fast. The molecules of the pen, which are cold, they are moving relatively slowly. So what will happen? You are used to feel some amount of collisions, some amount of rupture, some amount of energy on your skin. When you don't see that, because the molecules of the pen are cold, they will absorb some energy from you. You sense it as coldness. That is what exactly temperature is. So when you touch a body at a room temperature, you're used to it. That's why you don't feel any hot or any coldness out there. Yes, I hope that is clear. So Nirupam, in couple of lectures, but I will not make it really fast nor make it very slow, keeping in mind your exams are going to be in few weeks. Okay Nirupam, don't worry. Great. Now another important point, there is a lower limit for temperature which is called as the absolute zero temperature. Remember, the lowest possible energy, because temperature depends on the average energy. So what is the lowest possible kinetic energy, guys? Zero. So anything less than zero kinetic energy is not possible, because kinetic energy formula is half mv square. So you cannot have a temperature lesser than a particular value, and that temperature is called as absolute zero temperature. So very important pointers. I hope you guys are making notes simultaneously. Okay, next, what is heat? Come on guys, let's do this quickly. What is heat? Heat is not the amount of energy present, but it's the amount of energy which flows from one body to other. It's basically the energy which is in transit. And remember, heat always flows from a hotter body to a colder body. It will never happen the reverse way. Okay, unless you make it do artificially. You are taking the heat from this artificially. No. Naturally, it will always flow from, hotter body to the colder body. So heat is nothing but the flow of energy, or how much energy is flowing in transit. It's not the amount of energy contained inside the body, how much is flowing. And understand, a body never contains heat. It's wrong to say, मेरे में बहुत ज़्यादा heat हो गया. I have a lot of heat in my body. That's a wrong statement, guys, because it doesn't make sense. How can you contain a lot of heat? You can have a good temperature, you can have a high temperature, but you can't contain heat. Heat is when it flows. If it is not moving, then it is not called as heat. Keep that in mind. Okay, very, very important. I hope this is clear. All right. Yes. Well, temperature, why is it measured in negative values too? Well, it depends on the scale. So all those scales where the lowest temperature is zero and at absolute zero temperature, those are called as absolute scales, like Kelvin scale. But there are some scales where the zero of that scale and the absolute zero do not match. They are not the absolute zero scales, like degree Celsius. Yes. Yes, Ankit, they will come to whenever they are in contact. Sometimes, Ankit, even if they are not in contact, they can still transfer energy, and that is basically heat convection or radiation. You will see that. Yes, Ankit, there will be a separate chapter on that. So heat always flows from hot body to cold body. I just mentioned that to you. Very important points. I hope you have already noted it down, and we'll be coming to questions, guys. Come on, let's quickly revise all these concepts. I'm revising all the concepts so that it's there in your head, and this can act like notes for all of you. I'm giving all these pointers for your final preparation, be it in 11th, be it in 12th, doesn't matter, or even if you're a dropper student, all students can attend these classes. Next concept, thermal equilibrium. Like this animation explains to you, if you have two objects at different temperatures, one is hot, one is cold, the heat will flow from hot body to cold body. The temperature of hot body decreases, temperature of cold body increases till their temperatures become equal. So you will see the temperatures become equal, and that's when the heat flow process stops. They are said to be then in thermal equilibrium. As simple as that. You can see that very clearly one last time. So the temperatures eventually become equal. That's thermal equilibrium. So in the process of thermal equilibrium, the heat always flows, net heat always flows from hot body to cold body till their temperatures eventually become equal. That phenomena is called as thermal equilibrium. Very, very important. Very, very important. Now, I hope this is clear. Yes. At thermal equilibrium, what is same? Their thermal energy, or basically understand that temperatures are same. That's it. It doesn't matter. You can have a big object and a very small object. That big object might be very hot, that small object might be very cold. If you touch them, eventually their temperatures will be equal. Understand? Doesn't matter who is big, who is small, what is it made of, eventually the temperatures will be equal. So I'm guessing somebody is just using some random names in the names of the teachers. Asmi, don't worry about it. Okay, now what is the zeroth law of thermodynamics? Next concept, guys, quickly. I hope you guys are there. I hope the Josh is high. Yes, everybody is understanding all of this. Quickly we are revising all of this. Yes, everyone, all the minions. Very good, Bhargav, the trick worked. I read your comment. Very good, very good, very good. Excellent, excellent, excellent. Kirito, VK, Nirupam, Tape Face, Asmi, Tanmay, Sanspriya. Very good, very good. Now, zeroth law, very important. If a body is in contact with another body, okay, and you see that it is in thermal equilibrium with that object, and you see body B probably in contact with another body somehow, and it is in thermal equilibrium with this body, then even without testing, you can say that this body and this body are also going to be in thermal equilibrium. So that is, as simply put, the zeroth law of thermodynamics. If A's temperature is equal to B's temperature and B's temperature is equal to C's temperature, then without having to check using a separate thermometer, one can easily tell A's temperature is equal to C's temperature. You will be like, sir, what stupid law is this? Haven't you felt that this law is stupid? But I have a beautiful question which will tell you the significance of this law. I am 99% sure that most of you do not know it. Okay? So I'm going to tell the beautiful application of this law in a bit. So stay tuned, questions are coming up now. Here is the first question. When two bodies are kept in thermal equilibrium, then which of the following is true? Only one option is correct. Think about it carefully. When two bodies are kept in thermal equilibrium, then which of the following option is correct? Only one option is correct. Come on guys, think about it. Well, Princey, no. In normal situation, it depends. Right now, most likely, most of the things are in thermal equilibrium around in this room. But, you know, probably this screen is little bit hot. Probably I am having a different temperature. Probably that table is different temperature. So continuously heat exchange is happening at different points. Okay, a lot of you are saying D. Okay. Interesting. The correct answer is actually D. Very good, guys. Remember what was temperature? I just told you about this. Temperature is nothing but a function of the average kinetic energy. So if they are in thermal equilibrium, what does it mean? Temperature of 1 is equal to temperature of 2. If temperature 1 equals temperature 2, that means what? Their average kinetic energies are also same. So the average kinetic energy of molecules of A and B are equal. That's the answer. As simple as that. Let's get going to the next question. There are multiple options which could be correct in this. It's a multiple correct kind of question. Which of the following is or are true? Read the statements carefully. Coldest temperature of any body is minus 273 around. Temperature is dependent on the frame of reference. A large body at high temperature has more heat. A thermometer works on the principle of zeroth law. Come on guys, think about it, think about it. All right. No problem, even if you get it wrong guys, nobody is going to judge you. That's the speciality of Enthuse and the minions out here. Nobody judges anyone out here in spite of you giving all the wrong answers. Remember, we have all come here to learn. That's our common aim. Excellent, guys. So, some of you are saying AD, some of you are saying ABD, some of you are saying ABCD. Oh my god, that's us, me, nobody else. Okay, and somebody said ABC as well. Okay, AD, ABD. Well, the correct answer is A and D. Some of you got it correct. I can see at least Uncharted, I can see VK, I can see, I think, Princey also, and Sneha. Yes, very good. I might have missed some names, but yeah, these are the answers. Which of the following is our true? Coldest temperature, guys, 0 Kelvin is minus 273 degrees Celsius. That's correct. That's a standard thing. You would have learned it in chemistry as well. Temperature depends on the frame of reference. Guys, think about it. What is my body temperature? Almost 98 Fahrenheit or 37 degrees Celsius. And let's say you are at rest and you are observing me. Now you start running, or you catch a bus and sit inside the bus. Now will you say my temperature has increased, or will you say my temperature has decreased? Obviously not. Now body temperature will still be 37, no? You cannot say, oh no sir, I'm seeing you from a different frame, so the temperature will be different. Doesn't make sense. So temperature does not depend on the frame. Yes. Not sure Prince if Pandu will come today. Okay. And a large body at a high temperature has more heat? Well, that doesn't even make sense. I just told you a body cannot contain heat. Heat always flows. What is there inside a body is the energy, internal energy. It's not called as heat. Heat is something which flows. So this statement itself is wrong on its own. Okay, then yes, no problem, take face, no problem. Thermometer works on the principle of zeroth law. Now remember, I was just telling you about something. Zeroth law ka amazing application I'm going to tell you. This is where it comes. Now, why not bring Pandu? Somebody just was missing Pandu. So guys, let's us bring Pandu. Are you guys ready to bring Pandu in? So let's bring Pandu. Okay. So don't be sad guys. Pandu is coming in. Okay. So Pandu is sleeping like this, and his body temperature needs to be measured. And what is happening now? You have a thermometer. You have a thermometer. This is the bulb of the thermometer. This is that bulb. And this is the wall of the thermometer and all that. Okay. And there is mercury inside it, of course. This is that mercury which is there inside it. I'm just showing it in different colors. That's all. That mercury will expand or contract depending on whether the body is hot or cold. If it expands, the temperature will increase. If it contracts, the temperature will decrease on that scale. As simple as that. Now there are three bodies over here. This mercury, I will call it body, let's say A, okay. Then this bulb of the thermometer, I will call it, that bulb of that thermometer, I'll call it body number B. And our very own Pandu. So Pandu, I'll call him body number C. Eventually, after some time, the thermometer's mercury will stop expanding or contracting. It will reach a stable value. Once it has reached a stable value, don't you think guys, all of them are in thermal equilibrium? They have remember guys, they have now come to thermal equilibrium, correct? If it stops going up or down, now in thermal equilibrium, using zeroth law, guys, what can you say? Think about it. A is in equilibrium with B. B is in equilibrium with C. So A is in equilibrium with C. So temperature of mercury is same as temperature of Pandu. Temperature of mercury is same as temperature of Pandu. Do you agree with this? Using zeroth law, guys. This is using zeroth law. Very important. Now think about it. Is mercury touching Pandu or bulb touching Pandu? Is the mercury touching Pandu or is the bulb touching the Pandu? Obviously the bulb is touching the Pandu. So when you are actually measuring the temperature, whose temperature are you measuring? Are you measuring Pandu's temperature? Or are you measuring bulb's temperature? Or are you measuring mercury's temperature? Think about it. Actually speaking, you are only measuring the mercury's temperature, guys. You are actually measuring only the mercury's temperature. Then you will be like, sir, so we are not measuring Pandu's temperature. Yes, you are not measuring directly, but indirectly, yes. Why? Zeroth law. When you use mercury thermometer, you are only measuring temperature of mercury. But since mercury is in equilibrium with bulb and bulb is in equilibrium with Pandu, so mercury is in equilibrium with Pandu, so indirectly you are measuring the temperature of Pandu. This is the application of zeroth law of thermodynamics. Is that clear? Yes or no? And if you all loved this explanation, come on, go hit the like button, and if you are new, go hit the subscribe button. Is that clear, guys? Is that clear, everyone? Wasn't it interesting? How much time? Typically a minute. So generally you keep it under your arm for a minute and that's it. It comes to equilibrium almost. Excellent. Yes, Kirito. Yes, Kirito. Cool, 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 cool. Okay, very good. Lot of exciting questions coming in. Beautiful questions are on your way. Stay tuned. Okay, next concept, temperature scales, guys, temperature scales. Now let's talk about temperature scales. So guys, there are different units of temperature, Celsius, Fahrenheit, etc., etc. So you need to know the conversions and how to convert from one thing to other. Celsius to Kelvin is very simple. Everybody knows this. 0 Celsius is 273 Kelvin and minus 273 degrees Celsius is 0 Kelvin. Guys, this is the absolute zero temperature, lowest temperature, which I just told you some time back. This is your freezing point of water. This is your boiling point of water. Guys, let me tell you one simple fact. If you know any 2 points in this, you can find any other point's temperature. As simple as that. You just need to know any 2 points in this. Let's say I know the boiling point and let's say I know the absolute temperature. Same thing over here in Kelvin. Then I can find or convert from any Celsius to Kelvin or Kelvin to Celsius. I'm going to solve some problems for you. Don't worry. And this is very simple. I hope everybody knows this. And Celsius to Fahrenheit. I'll tell you guys, very easy formula. Remember this. So what is the formula? Remember, in Fahrenheit scale, okay, in Fahrenheit scale, the water's freezing point is 32 degree Fahrenheit. You should remember this. Very important number. Water freezes at 32 degrees Fahrenheit. Obviously, guys, come on. It will be lower in Fahrenheit. 98 Fahrenheit is 37 degrees Celsius. So 0 degrees Celsius will be slightly lower Fahrenheit. Now, in order to convert it into different scale like Celsius, this is what you need to do. Guys, there is a number which comes like 5 by 9 or 9 by 5. So let's say I want to convert it into degree Celsius. I know the temperature in degree Fahrenheit. Understand, if you are going from Fahrenheit to Celsius, you are going from a more sensitive scale to a less sensitive scale. What are you going from? You are going from a more sensitive scale to less sensitive scale, guys. Very, very important. Why is it more sensitive Fahrenheit? Guys, I'll tell you simple fact. What is your body temperature? 37 degrees Celsius. If I tell you tomorrow your temperature is 37.5, you'll be like, fine, it's 37.5, not a big deal. But if I tell you your body temperature is roughly around 98 normally, tomorrow I tell you your body temperature is 100, you'll immediately probably think I might have corona. Hai na? Won't you think I have corona or something? Hai na? If your body temperature goes near 100, you will get scared. So guys, in Fahrenheit, what happens? The temperature value changes by a lot for the same change. So that's why it's said to be more sensitive. That's how it is. Yes. So you are going from more sensitive to less sensitive. So multiply by a number less than 1 and that number ratio comes out to be 5 by 9. So 5 by 9 is the number. And then if you put 32, you should get 0. Think about it, guys. If you put 32, you should get 0 in Celsius. So F minus 32. That's how you remember this formula. Very easy. Remember this, as simple as that. All right, great. Shall we go ahead now? Let's solve some problems. Let's solve some problems. And to solve the problem, guys, okay, let me tell you a very magical trick. Very interesting magical trick. So guys, listen to me. If you want to convert from any scale to any other scale, let's say there is an X scale, there is a Y scale, and maybe I know the freezing point in this scale, and maybe I know the boiling point in this scale. Let's say the freezing point is X1 in X scale and Y1 in Y scale. Boiling point is X2 in X scale and Y2 in Y scale. I want to know how much Y is it for a certain other value of X or the other way around. I want to know what is the relationship in general between X and Y for any other value of temperature. Very simple. Remember straight lines. This is X-axis, this is Y-axis, and all you need to do is think of a linear relationship. For this value, it is this much. For this value, it is this much. For this value, how much? straight line equation, and you would have learned this in straight lines, and if you have not learned it, I am telling it to you, you will eventually learn it. Don't worry about it. One point x1, for this point x1 you get y1, for another point x2 you get y2. Okay, so guys, for some point x, this is the value of y you get. Guys, do you know the equation for this? Yes, don't have to use y is mx plus c. This is 2-point form. 2-point form is x2 minus x1, or you can also use y2 minus y1 first. So y2 minus y1 upon x2 minus x1 is nothing but y minus y1 upon x minus x1. Use this formula which you already know from maths. That's it, you will get the answer. You will know all these 4 numbers and any one of this. You have to find the other. That's it. Use this formula and you will get it. I hope this is clear. I hope this is clear, guys. Everybody understanding this? Interesting? Yeah, very simple way. Don't have to do it in very weird ways. Very simple. All right, let's get going then. Let's solve a problem. Let's see how many of you do this. On a thermometer, X, the freezing point is minus 30 and the boiling point of water is at 90. So the question is 60 degree X is how much? That's the question. On a thermometer, freezing point is at minus 30, the boiling point is at 90, guys. Oops. Yeah, so the question is 60 degree X is how many degrees Celsius? Come on, think about it. Let's see how many of you give the answer really quick. Let's start doing it for all those people who want help and assistance. No problems, I'm there for you and I'm going to solve the problem on board. So let's do this. I am going to draw simple 2 lines, X, Y. Let me think. Thermometer X, the freezing point of water is at minus 30 degrees Celsius. So let's say our Y over here is nothing but in degrees Celsius. Remember, freezing point, water freezes at 0 degrees Celsius. So when degree Celsius is 0, okay, on X scale it is at minus 30. So this is minus 30. So here x1 is minus 30, y1 is nothing but 0. As simple as that. Next point, boiling point, that means 100 degrees Celsius is at 90. So over here, this is that boiling point, and here x2 is 90 and y2 is nothing but 100 degrees Celsius. Now the question is 60 degree X. So when X is 60 degree, Y is how much? Now you know, guys, what to do. Very good. Some of you have already got the answer. Excellent. So guys, use our formula. Y2 minus Y1 divided by X2 minus X1 is equal to Y minus Y1 upon X minus X1. Y2 minus Y1, 100 minus 0. X2 minus X1, 90 minus minus 30. Be careful. So it will become 90 minus minus 30, which will become plus 30 in the later on part. Okay. And Y minus Y1. Oh, I don't know why. Minus Y1, 0 upon X, 60. 60 minus X1, 30, but minus 30 actually. That's it. Now solve this. You should get the answer, guys. Did you understood? Understood, guys. Now this will help you not just for this problem, any complicated problem also it will help you. For some simple problems, it might look little bit tedious, but believe me, this method will always work. That's the whole idea. Very good, Kirito. Yes, it's all about ratios eventually. Y2 minus Y1. Yes, all about ratios. Now it looks easy. So guys, if you visualize it this way, it will always look easy. That's all. Correct. So the value of Y, check it out, guys. 90 plus 30, this is nothing but 120, and over here 60 plus 30, this is nothing but 90. Come on, guys, move it up, rearrange and see what you're getting. Come on, guys, are you getting it as 75? That's me, not today. Okay, a lot of stuff to cover, but maybe some other day. Okay, 75, very good. Let's check the answer. If it is 75, yes, it is 75, guys. Very good. Now you will never face a problem in conversion of scales. If you have learned some weird, complicated ways, please forget that. If you have been taught some other ways, please forget that. This is the easiest way. I am telling it to you. Yes, it is at the end of the day tape phase unitary method only, but it will work. Unitary method will work when the scale starts from 0. Here it might start from somewhere else also. 0 might not be 0 in both the scales. So that's why better than unitary, use this. It will help you better. Okay. Now, let's talk about the main topic. And there are a lot of misconceptions which people have. Some people don't even know that it's a wrong concept. I am going to teach you thermal expansion in a very different way. Yes, you will see it why. No problem, Ankit. No problem. Okay. So, alright, I guess I have answered all the doubts, most of them. Okay. Chalo. Perfecto. Alright. Now, look at this simple simulation, guys. There is a rod which is fixed at one end, this orange color rod that you can see. And it is placed on a roller here. That roller has a needle and some markings on there. If you heat the rod expands. And as the rod expands, it will turn that roller. And you will see that needle will bend. It will tell you how much the rod has expanded. If you again cool it, it will come back. If you heat it, it will slide again. So that's what is happening. So guys, is there a relationship between temperature and length? Yes, there is, and that's what we are going to see. So whenever you heat something, it expands, and whenever you cool something, it contracts. But the amount of expansion that each material undergoes is different even when you heat it by the same amount, because each material has a different characteristic till which or how it expands. So probably, aluminium or ceramic plates or maybe wood might not expand so much, but steel, iron, etc. expand a lot. You can see for the same heat provided, the expansions are different. That's how it is. Alright, I hope this is clear. Okay, cool. Now comes the most important slide. Guys, what if I tell you entire thermal expansion can be taught over here in this one slide? You won't believe it, right? But I'll make you believe it. Okay, looks like a donut. I'm already hungry, yaar. Shit. Why did donut come over here? I'm so hungry now. Okay, anyways. So let me tell you what is the thermal expansion formula and what are the concepts in this and what are the misconceptions in this. Oh yes, but there are some exceptions. Yes, there are some exceptions that, for water, it behaves anomalously, because when you heat it between 0 to 4, instead of expanding, it contracts. So that's a special case, but there are very few exceptions like that, but usually things will expand. Now, listen to me. Any body you take, any random body, any random shape, maybe we couldn't find any other random shape, so we got a donut. Okay. You take any 2 points on it, guys. Any 2 points. What am I saying? Take any 2 points on it. Doesn't matter where they are, but it should be on the same solid. Very important. This is point A. This is point B. Measure the distance between them. Measure the distance between these 2 points A and B. Let's say it is L0. So what is L0? Is the original distance. I'm not dictating all these things, but it will also come in the extracts. If you don't know what extracts is the summary of this chapter. So all the pointers, mean, formulas, etc. will come there, but does not mean you should not make notes. Keep making notes, because that's the way it will enter into your head. Now, if you heat this body, it expands. Wow. Now we have a bigger donut. Excellent. So now, these are the 2 points. A, B, original distance was L0. Now, because I heated it, this point A, I hope you guys can see, would have shifted to A1, and this point B would have probably shifted to B1. I hope you guys can see those points A1 and B1, guys. I hope you can see that. Excellent. Ankit, I'm not sure. Maybe you need to check online. Alright, what are the coefficients of expansion and all that. Now, the new distance between them, is L, and delta L is basically L minus L0, which is nothing but expansion, or basically I would just say L minus L naught, or I would just say change in length due to delta T. What is this delta T? Temperature change. So you have changed the temperature, that's why the length has changed by delta L. Now experimentally understand, if you find out what is the relationship, it turns out delta L is proportional to delta T. Yes, it comes out to be proportional to delta T, and that constant of proportionality, don't get confused, this is proportional symbol, not alpha, is equal to, L naught alpha delta T. This is what the final answer comes out to be. Now let me tell you what each term is over here. Everybody knows L naught. L naught is nothing but original length. This is nothing but the original length. Delta T is change in temperature. This alpha is called as the coefficient of linear expansion, and the units you can see, length cancel, so per degree Celsius. So the units is per degree Celsius or per Kelvin or per Fahrenheit and stuff like that. What does this tell you? It tells you how readily it will expand or contract. If alpha is more, it's more sensitive. Like steel will have higher alpha, materials like wood, plastic, etc. will have less alpha. If alpha is 0, that means no matter how much you heat it, it does not expand. If alpha is very large, then it expands even with the slightest increase or changes in the temperature. And this alpha basically then depends on the material. So it depends on the material, just like coefficient of friction, coefficient of viscosity, density, and so on and so forth. Yes. All right. I hope this is clear. Is this clear, guys? This is the formula. Now I'll tell you what is the biggest misconception. Biggest misconception which people have is that, sir, why the hell did you take this object? In our class, in our normal whatever coaching, etc., we were told take a rod, expand it, this is L naught, this is delta L, and this is the total length L. Use it for rods, Now why the hell are you not taking a rod? Guys, that's what the wrong thing is. It's not valid only for rods. It's valid for anything. You take these 2 points anywhere on any random object, as long as they are the same object, it will work, this formula. Even if there is nothing in between, do you see how I have drawn that line? There is nothing in between. Even if it is like that, you will see the distance between these 2 points will increase. Very important. Yes, this is called as linear expansion, because I am talking about length, guys. Is that clear? No tip phase. They might not be even on the same plane. Okay, just I'll give you an example. Imagine you just say statue. I'll become like this. I'll freeze. Now I've frozen. Okay, I can just talk, but my other body parts can't move. Now, if you take the distance between my watch and probably my chest, my heart out here, you measure the distance. Probably there is empty space over here, guys. Empty space over here. You measure the length, and let's say you make me hot, you make me angry, I become really hot. Now the distance between these 2 points will increase. It doesn't matter what is there in between, as long as they are on the same body. That's what matters. Okay, statue over. Yes. I hope this is clear. Excellent. Everybody understanding this? Very good. Next comes is aerial expansion, guys. Again, same thing. You take a patch on that surface. It could be on the same plane, not on the same plane, doesn't matter. A patch anywhere. Now, well, yes, it is possible that it does not expand linearly, Nirupam, but there are very few exceptions like that. Most of the objects under normal situations will expand linearly. Yes. Now, yes, railway track is an example. Yes, railway track is an example. So, if the original area was A naught, and you see because of the expansion, that patch becomes big. New area is A, and delta A is basically change in area. Guys, the formula now is delta A is equal to A naught instead of alpha beta delta T. That's the only change. That's it. Instead of alpha there is beta. And what is beta? Coefficient of areal expansion. What is the unit? Same like before. Areal, okay, expansion, and units is, you know, per degree centigrade or per degree Fahrenheit or per Kelvin. That's how it is. No, Saurav, I didn't ignore you. I just told you it is railway track is an example. I just told, right? Yes, area is surface area. No, tape. A is not the surface area. It could be even the surface area or maybe a small part of that complete surface. That's what I want you to realize. Here, A does not necessarily mean the complete area. It could be even a small part of it, but as long as you are seeing that same area, how it expands and what is the new area, this relationship will always hold true. Yes. I hope this is clear. I hope this is clear. Okay. Fine, guys. Excellent. Excellent. Very good. Very good. Last thing, guys. You again take a small volume. Take a small volume. It could be of any shape. This entire volume which is there, it could be entire volume of that donut or that rigid body, or it could be some part of it. This is V0. You expand it, you will see the volume will also increase, something like this, maybe. Okay, I've just shown it randomly. So the new volume is V, and guys, the difference between them is delta V, which is change in the volume. This delta V will be V0 gamma delta T. So guys, think about it. What is this gamma? This is nothing but coefficient of volume expansion. That's it. As simple as that. Yes. Correct. I hope this is clear. Can it be area if there are 3 points? Yes, tape face. So let's say if you are talking about area, if you take 1 point here, 1 point here, 1 point here, you join those 3 points, then you obviously have an area. You can make a triangle over there. Yes, why not? Understood? Yes, there are questions on this topic and I'll show you those. Now the last point over here, what is the rishta? What is the relationship? How are they related to each other? Remember this, guys, very important. Alpha and beta are related like this. Beta is area, right? Area is square times power is 2. So it is 2 alpha. Volume is cube in dimensions, all right, of length. So gamma is 3 times of alpha. So remember this relationship, very important. Beta is twice alpha, gamma is thrice alpha. All right, yes, 1:2, 2:3. Great. Very good. Are you guys now ready for some problems? Let's do this. This was asked in 2020. Advanced, yes, advanced question, guys. Let's see how many of you can do this. Advanced question, recent paper, September. 2 different wires having lengths L1, L2 and respective temperatures of coefficient of linear expansion alpha 1 and alpha 2 are joined end to end. Then the effective temperature coefficient of linear expansion is. Come on. So Saurav, let's say for example you know the coefficient of linear expansion for steel, but you want to see how much volume changed. So from alpha you first need to find gamma, and from gamma you will find the volume change. So that's why you might need to convert. I hope, Saurav, that's clear. No, it's not subjective, but I'm not given you the options. I've hidden the options. Come on, think. All right, come on guys, let's see how many of you get this. Okay, so let's do this. I'll be solving it on the board just for some people who want some help. Okay, so both these rods are joined one after the other like this. Their lengths are L1 and L2. This is having alpha 1, this is having alpha 2. Okay, I want to know, can I convert it into one single rod which has 1 alpha equivalent and the total length L1 plus L2. So what is that alpha is what the question is. What is the coefficient of linear expansion effectively? So guys, think about it. When you expand this system, each rod will expand, and because of that, the total expansion, all right, the total expansion in the first situation, delta L, which will be because of 1 plus 2 totally, will be delta L1 plus delta L2. What is delta L1? It will be L1 alpha 1 delta T. What is delta L2? It is L2 alpha 2 delta T. Delta T is common, we will take care of it later on. In the second situation, if you heat the equivalent rod of length L1 plus L2, it should expand by the same amount in order to behave like an equivalent rod. So it should expand by the same amount. So that means delta L equivalent, all right, of that rod will be initial length is L1 plus L2 alpha, I don't know, into delta T. Now just equate these two, guys. Just equate these two. These two should be equal. That's it. So just do this and you will get the answer. So L1 alpha 1 delta T plus L2 alpha 2 delta T will be L1 plus L2 into alpha into delta T. Delta T, delta T, delta T gone. What is remaining is alpha, and alpha is L1 alpha 1 plus L2 alpha 2 by L1 plus L2. That should be the answer. I hope this is clear. I hope this is clear. Very good. I hope this is clear. Everybody understanding this? Everybody understanding this? Shall we go ahead? Let's check the answer, whether what we have done is correct or not. Yes, it is correct. Bingo. Cool. Yes, so sometimes simple questions also come na in JEE Advanced. Okay, so what did I tell you when I started the lecture, guys? Where were you? Didn't I tell, guys, this chapter is easy and it is scoring, so don't skip this chapter. If you get a question from this chapter, you have to do it. You have to get those points, you have to get those marks, guys. Come on, next question coming up on your screen. 2017 question. An external pressure P is applied on a cube at 0 degrees Celsius so that it equally compresses from all sides. K is the bulk modulus of the material of the cube, alpha is the coefficient of linear expansion, and suppose we want to bring the cube to its original size by heating, then the temperature should be raised by, come on, think about it, how are you going to do, and let's see how many of you give the answers before we solve this. Come on guys, come on, I want you to solve this. Come on, quickly, think about it, okay. Chalo, let's solve it simultaneously as well. Now, basically what is happening, because of the pressure, you know, the cube gets compressed from all the sides. Achha, which concept is this? Think about it. That cube, all right, this is the concept of elasticity, because you are applying some pressure from everywhere. You know, what is happening? The cube is getting compressed. So I have a feeling we can find the strain involved in this. And what is the formula? Bulk modulus, remember, is nothing but the stress which you create divided by the strain. So guys, what is the bulk modulus? K. What is the stress? An external pressure P is applied, so that means it is P divided by strain. So that clearly tells me the strain is nothing but P divided by K. K is given to be the bulk modulus. Okay, this part is done. Now, when it compresses because of that pressure, now you want to bring it back to its original size by heating. Achha, so that means the concept of, you know, thermal expansion is there. So the cube expands everywhere just because you have heated it. So whatever strain was produced should be nullified. And guys, what is the formula for volume expansion? Delta V is V naught gamma delta T. Correct? Now think about it. What will be delta V by V naught? It will be gamma delta T. And what is exactly delta V by V naught? It is nothing but the strain. Change in volume upon original volume is nothing but the strain, guys. I hope this is clear. Yes. And Gamma, oh, gamma is not given, alpha is given. Coefficient of linear, be careful, a lot of people made a mistake there. Alpha is given, convert it into gamma. Gamma is 3 alpha into delta T, guys. What is the value of strain? I just figured it out over here. So just substitute. Epsilon is P by K. So P by K is nothing but 3 alpha delta T. So what was the question? The temperature, it should be raised by. So delta T, guys. Delta T will be P by 3 alpha K. That should be the answer. I hope this is clear. 2 chapters combined in one question. This is how JEE will ask you. Very interesting. I hope everybody has got this question now. Excellent. So, yes, P by 3 alpha K. What a question, guys. What a question. All right. Excellent, guys. Excellent. Now, let me teach you the next concept. Apparent expansion. Very good question on apparent expansion, where 2 objects could be expanding. Guys, there is an object whose length is measured to be 20 centimeters in length using a scale at room temperature. On a hotter day, the length measured will be options more than 20, less than 20, or equal to 20, or cannot say. Guys, come on, come on, come on, come on. Very good, Dhanush, Manjunath, Vijay Kumar, Nirupam, Priyanka, Princey, Krito. Very good, Yalni, very good. Saurav, very good, VK, very good. Come on, guys. Yes, what should the answer be? Should it be more or less on a hotter day? All right. Some of you are saying less, some of you are saying more. Kya baat hai? Uncharted saying more, Priyanka saying more, Saurav saying more, Manjunath saying more, everybody saying more. Very few people, I think only Tape Face said less. Okay, well, what if I tell you none of you are correct? None of you are correct, yeah. None of you are correct. You guys are not reading it carefully. Acha, now you guys will start saying less. Hai na? I know this is going to happen. Then you will say, sir, equal. Then you will say something. For every reaction of mine, you will start changing the answer. That is not correct, guys. So let us take an example. Guys, this is a wooden scale. This is a steel scale. This is an object. Wooden scale, steel scale, and object. Okay, 3 things out here. This is now at room temperature. You measure the length using wooden scale to be something, using the steel scale to be something. Look at that. On steel scale, it is something around 7 centimeters or something. And on the wooden scale, I don't think you can see it clearly, but it's around 11 centimeters. Okay, just take my word for it. It's 11 centimeters around. Now, I know you guys have now understood it. Yes, some of you have now understood it. Very good, very good, very good. Now I heat it by the touch of my finger on the board. It has got heated up. Wood will hardly expand, guys. Wood has very low value of alpha, but the object might expand. Okay, depends what that object is also. The object might expand. Now, if you are using a wooden scale, earlier we were measuring around 11 centimeters. Now, because it has expanded, oops, my bad. Because it has expanded, you will end up measuring more length using that wooden scale. Correct? See, you will see the marking coming over here at 13 centimeters. So, according to you, the object has expanded. But if you use a steel scale, even the steel will expand. Look at that. Earlier, you were measuring the length to be 7 because it expanded. See, guys, 7 is over here. But let's say the steel expanded even more. Let's say the steel expanded even more. I don't know, right, what kind of object it is. Then the answer might go behind that. I hope this is clear. I hope this is clear. Got it? Everyone? Yes, so the answer is depends. Can't say. Can't say. Yes, it will help you in aerospace for sure. Guys, believe me, if you measure a steel object using a steel scale, what will be the reading? If you measure the steel object using steel scale, what will be the reading at any temperature? It will be always be same. It will be always be same because that object is also steel. The steel scale is also made of steel. Both will expand equally. So you will never see a difference. So you will be like, sir, I am heating this object so much. Why is the object not expanding? Maybe this object is really special. I'll be like, hey, come on, man. You are measuring a steel object using a steel scale. What else will you expect? I hope you get that, guys. Let's go ahead. Very good. Easy peasy. Next, last concept, guys. Come on, get ready. Thermal stress. Thermal stress. What is thermal stress? There is a rod. Okay, I'm holding it like this. I heat it. What will happen? What will happen if I heat it? Obviously, it will expand. This is a rod. I heat it. It will expand. Isn't that correct? Now, I hold the rod like this. Constrained. I'm holding the rod like this. No pain, no gain. No stress, no strain. Correct? Okay, very good. Now, I heat the rod. What will the rod say? Hey, please allow me to expand, man. Move. Just move. Please move out of my way. Let me expand. So what will happen, guys? Stress. That is called as thermal stress. I hope this is clear. Correct. Excellent. That is what is going to happen. So that stress is called as thermal stress, and the formula for that is very simple. Remember this. When you constrain that rod, the thermal stress developed is Y alpha delta T. Remember this formula. What is Y? Young's modulus. What is alpha? Linear expansion. What is delta T? Change in temperature. What is sigma? Stress. Unit Newton per meter square. Stress it is, not force. Be careful. Excellent, guys. Very good, very good, very good. Yes. Thank you, Kirito. That's a statement, a quote by me for this year. Very good. Yes. Now let's solve a problem on this. That's the last question for today, guys. Get ready, get ready, get ready. A rod of length 2 meters at temperature 20 degrees Celsius. When free expansion of the rod is allowed, okay, and you are expanding the rod to 50 degrees Celsius freely, you are expanding it. How much stress is produced if the rod is not allowed to expand, only completely prevented, just like the diagram before? And second situation, it's permitted to expand but only 0.4 millimeters. Then what will you do? Okay. Thank you, Manjunath. And teaching should be fun, because that's the tagline of Vedantu, guys. What's the tagline of Vedantu? Yeah. Come on. Let's do this. First part. If it is permitted, guys, can you hear me? Guys, can you hear me now? Okay, I'm not sure why my internet went out. I'm not sure. Yes. I'm back. I'm not sure why it went out. And I was teaching, and then I suddenly look out, like no minions out there, no minions chatting on the screen. Then I realized, oh my god, the internet connection has gone. I'm so sorry. So guys, I was just telling you, I'm not sure which point you lost contact, but here is the answer. And I hope meanwhile you're also solving. Thermal stress is Y alpha delta T. Yes. And Y is given, alpha is given, delta T is given. So the value of thermal stress is 9 into 10 to the power 7. So that's the first answer. But how will you solve the next part? That is very tricky. So here is the logic, guys. Observe this. First, see how much does it want to expand. How much does it want to expand? So delta L will be L0 alpha delta T. What is L0? L0 is 2. What is alpha? Alpha is 15 into 10 to the power minus 6. And what is delta T? It is 50 minus 20. So guys, this will be, just check this out. I hope this is correct. 15 2s are 30. 50 minus 20, 30. 30 into 30, 900. So it will become 900 into 10 to the power minus 6. Which is nothing but 9 into 10 to the power minus 4 meters. Okay. Now, once I know this, look at it. The rod is only permitted to expand by 0.4 millimeters. 0.4 millimeters is 4 into 10 to the power minus 4 meters. It wants to expand. It wants to expand, guys. think about it, by 0.9 millimeters or 9 into 10 to the power minus 4, but you are allowing it only by 4 millimeters. So how much is the actual delta L? The actual delta L will be 9 minus 4 into 10 to the power minus 4, which is nothing but 5 into 10 to the power minus 4. I hope this is clear. I hope this is clear. I hope this is clear. Yes. Okay, Alni, I'll just tell. I think some of you missed few points. So guys, over here, you know, the rod is of original length 2 meters. The temperature is initially at 20. You change the temperature to 50. So the rod will expand. First situation, it is completely prevented. It does not move only. It does not move only. Okay? So for that, what is the formula? So when it is completely prevented, the thermal stress formula is Y alpha delta T. Remember this. This is the formula, Y alpha delta T. Correct. So that is the formula, guys. Yes. So that is the formula. I'm not sure why the internet is acting so weird, but sigma is Y alpha delta T. I hope this is clear. Okay. Now in the second situation, when you allow it to expand only by 0.4 millimeters, what I'm trying to do, first I'm trying to see how much does it actually want to expand. I figured it out using thermal expansion formula, L0 alpha delta T. This is the value I got. But you are permitting it by only this much. So how much will it actually expand? Or how much is the stress? You know, how much is the basically, see, this was the want. Okay. How much are you exactly changing the length by? This is basically the actual change in length. This is that actual change in length which has happened. I hope this is clear. Yes. Now what you can do? No, you cannot do that, Kirito. Stress is not a scalar quantity, so you cannot add or subtract stress. Even if you get the correct answer, that method is wrong. So that's why we can add lengths. They are scalars. So that's what I'm doing. From this, find the strain. What is the strain? Delta L by original length, which is 9. Sorry, my bad. Not 9. 5 into 10 to the power minus 4 divided by original length 2. From strain, you can find stress, because remember Young's modulus is stress by strain. Therefore, stress is Young's modulus into strain. So guys, think about it. What will you get? Sigma is Young's modulus. How much is it? 2 into 10 to the power 11. What is the strain? This much. 5 by 2 into 10 to the power minus 4. 2 gone. I think only 5 is remaining. Just check it out. So only 5 is remaining. So 5 into 10 to the power, come on guys, 7. That should be the answer. I hope this is clear. I hope this is clear. Yes, that's the Dukh Bari Dasta, Sneha. What can I say of all the online teachers out here? We are completely dependent on the network, YouTube and other things, other tech out here. All right. Yes, thank you guys for all the support and all the patience that you guys have. Very good. This is what I want. That's all. Just give me the support. I'll be there for you. Don't worry. I'm there always for you. Very good. Okay. Great. So guys, yeah, we got the answers. And these are your homework questions. What temperature, Fahrenheit and centigrade values are equal? That's the first question. Put it up in the comment section after the video ends. And initial length is given and final length is given. Final temperature is given. Coefficient of linear expansion is given. What is the initial temperature has been asked. Figure it out. I'll be posting up the solutions on our Telegram group. Do check it out. The link is in the description box below. And guys, for all the 12th standard and dropper students, if you are loving my teaching out here, guys, this is the kind of teaching we do even in Vedantu, plus some additional things. See, we cannot do everything on YouTube because tests have to be conducted. Then, you know, you need to have the doubt solving. There is multi teacher support, doubt assistance, even after the class, plus, you know, revision sessions, 45 revision sessions, and, you know, full syllabus test series, part syllabus test series, everything will be done over here in the crash course. So understand, if you are interested, definitely please give it a thought. Check out the description links now, okay? And in that you will see the course details, everything. The course price usually is 10,000, but on YouTube you get 20% off using the coupon code SHCC21. So use it and definitely you'll be benefited. You can also pass it on to any of your known relatives, friends, etc. Thank you guys. Thank you, minions. What a lovely day. And I hope all the new minions out here have already subscribed. And guys, please keep sharing these videos with any of your friends and bring in more friends if you have out there who are studying, like-minded minions out there. And I hope you have already liked this video as well. Come on, show us your support, because that's all we are asking for. Thank you guys. Bye bye. Tomorrow another interesting session, but I don't remember what the session was, but yeah, we'll have another interesting session tomorrow at 7 o'clock. So always remember, 7 o'clock you will find me over here, Shreyas Sir. Okay, bye bye, take care, have a great night ahead.